Imagine waking up on a Tuesday morning in 2060. If you were born in 2000, you are 60 years old today, but your biomarkers say you're 41. You haven't seen a doctor in a decade because your blood screens itself for disease every hour. You haven't driven a car in 15. Nothing with a steering wheel is legal on a city street. And despite having 0 employees, your AI-driven company just cleared $40 million. Outside your window, a cargo drone from the lunar surface hums past, making its 3rd delivery of the week. To you, this isn't a miracle, it's just Tuesday. We are approaching the Great Convergence, the moment where 30 independent technologies, from fusion energy to longevity escape velocity, hit the peak of their curves at the exact same time. This is the era where AI compresses a century of science into a single year, and where work is no longer the primary source of human meaning. This isn't science fiction, this is a trajectory. These technologies are already funded, they are already in clinical trials, they are already climbing the exponential curve. The question isn't if this world arrives. The question is whether you understand the map before you get there. 30 technologies, 35 years. Here is every one of them. Number 1. Fully autonomous vehicles. In 2024, global electric vehicle sales crossed 17 million units, more than 20% of all new cars sold. That was not a technology story. That was proof that a century-old industry could turn fast when the cost curve broke in the right direction. But electrification was phase 1. Phase 2 was removing the driver entirely. By 2060, the privately owned car has largely vanished from city centers, replaced by a seamless fleet of autonomous pods, summoned by voice, arriving in 90 seconds, never tired, never distracted, never checking a phone. Urban road fatalities drop by over 90%. The land previously buried under parking lots, in some American cities, 30% of all surface area, converts to housing, parks, and community space. The car did not disappear, it became something far more useful.
Number 2. Ubiquitous Robotics. The International Federation of Robotics was already tracking hundreds of thousands of new industrial installations per year in the mid-2020s. That installed base doubled, then doubled again. But the robots that changed daily life were not the factory arms. They were the ones that came home. By 2060, the domestic robot is as unremarkable as the dishwasher, handling laundry, groceries, elder care, basic cooking, and home repair. Robotic surgical systems, guided by AGI, perform sub-millimeter procedures at 3 in the morning with no fatigue, no ego, and no malpractice anxiety. Fully robotic construction crews erect structural frames in a fraction of the time and cost of human teams. The robot did not replace the human. It replaced the parts of the human day humans had always resented most. Number 3. AGI as Scientific Substrate. This is the one that accelerates everything else. Pay attention. In 2021, DeepMind's AlphaFold solved protein folding, predicting the 3-dimensional structure of virtually every known biological protein. A 50-year problem solved by pattern generalization. The database it produced, freely available to every scientist on Earth, reshaped drug discovery almost overnight. That was the template, not a conscious machine, a pattern engine generalizing across scientific domains at speeds no human team could match. By the late 2030s, the same architecture was running in materials discovery, climate modeling, aerospace engineering, and pharmaceutical design. Self-driving laboratories, robotic systems that chose their own experiments, ran them, analyzed results, and iterated in closed loops, compressed drug discovery from years to weeks. The constraint on scientific progress shifted from computation time to imagination. Everything else on this list flows downstream from that fact.
Number 4. The death of cancer. Here is what we already knew by 2025. The FDA had approved Casgevy, the first CRISPR gene editing therapy for sickle cell disease. It worked, repeatably. The regulatory pathway for gene editing at scale now existed. Separately, Moderna and Merck had documented a 44% reduction in melanoma recurrence in Phase 2 cancer vaccines. These were not promises, they were peer-reviewed results already in clinical use. By 2060, most cancers are caught before they become cancers. Circulating tumor DNA detected in a routine morning blood draw years before a tumor forms. CRISPR-edited immune cells destroy what slips through. Personalized vaccines close the remaining gap. The war on cancer was not won. The front lines moved so far that most people stopped noticing the war. Number 5. Anti-aging drugs. Aging is not a single process. It is a layered stack of interacting failures, cellular senescence, genomic instability, epigenetic drift, mitochondrial decay. No single drug fixes all of them. But by the mid-2020s, the science had established that some layers were therapeutically addressable. Senolytic drugs, agents that selectively clear the senescent cells that poison surrounding tissue with inflammatory signals, were advancing through clinical trials. Partial reprogramming, resetting epigenetic age markers without triggering cancerous dedifferentiation, had shown extraordinary results in animal models. By 2060, biological age reset therapies are in widespread clinical use. A 63-year-old in an advanced economy is biologically closer to 41 than to the 63-year-olds of 2025. The ethical and political consequences of this are explosive. We will come back to them.
Number 6. Organ regeneration. In March 2024, surgeons at Massachusetts General Hospital transplanted a genetically modified pig kidney into a living human recipient. The patient lived. The organ functioned. That single event opened a door the transplant system had been waiting in front of for 40 years. By 2060, engineered pig organs, CRISPR-cleared of immune rejection triggers and latent viruses, are a standard bridge for kidney and cardiac replacement. Bioprinted scaffolding seeded with a patient's own stem cells are beginning to replace them where available. The transplant waiting list, which killed tens of thousands annually in the 2020s, is effectively eliminated in advanced health systems. The result is not just longer life, it is longer functional life, and it reshapes everything from retirement age to pension mathematics. Number 7. Vertical farming and precision agriculture. By 2060, 10 billion people need to eat. Climate change is reducing yields in key agricultural zones. Traditional livestock farming is consuming river systems that coastal cities also need. Something had to give. Vertical farms, sealed, multi-story growing facilities with LED arrays tuned to optimal photosynthetic wavelengths, produce leafy greens, tomatoes, and strawberries year-round in urban centers, using 95% less water than field agriculture and no pesticides. Autonomous tractors and robotic harvesters, guided by satellite imaging and AI crop modeling, have made outdoor farming radically more efficient, applying fertilizers with surgical precision, eliminating the waste that once ran off into watersheds. Food in 2060 is not more expensive, it is more reliable. Number 8. The end of the smartphone. It lasted about 50 years. Not bad for a glass rectangle. The smartphone was not killed by a competitor, it was made redundant by something it could not compete with: context-aware spatial computing worn on the face. Lightweight AR glasses that overlay digital information directly onto physical reality, a colleague's name appearing as you approach, navigation lines drawn on the floor ahead of you, a menu's nutritional breakdown materializing beside each dish, have moved the interface from your pocket to your field of vision. The underlying shift is more significant than the hardware. AI systems now understand what you are looking at, what you are likely to want, and what you need to know without being asked. The device became invisible because the intelligence became ambient. But the most significant interface shift of 2060 is not on the outside of the skull.
Number 9. Neural implants. January 2024, Neuralink implanted its first device in Noland Arbaugh, quadriplegic from a diving accident. He used it to control a computer cursor with his thoughts, played chess online, and described it as getting his life back. By late 2025, 9 participants across the US, UK, and Canada carried implants. The FDA granted breakthrough designation for speech restoration. Competing companies, Synchron, Paradromics, were advancing their own programs. This was the beginning. By 2060, neural implants have moved from medical necessity into elective cognitive augmentation. The gap between an implanted person and a non-implanted one in memory recall, processing speed, digital control is the cognitive equivalent of the gap between a smartphone user and someone without one in 2010. Not a gap, a chasm. The ethical debates, who owns neural data, what happens when the manufacturer goes bankrupt, what cognitive inequality means when enhancement is priced at a premium, are the defining political arguments of the decade. The technology is real, accelerating, and it is not waiting for the ethics to catch up. Number 10. The Metaverse as infrastructure. Forget 2022. Forget the empty virtual malls and the clunky avatars. That version failed because the technology wasn't ready and the experience wasn't worth the discomfort. By 2060, spatial computing married to neural interfaces has produced something entirely different. Persistent, photorealistic shared digital environments, indistinguishable from physical space for most professional purposes. Architects walk through buildings not yet built. Surgeons rehearse rare procedures. Engineers stress test components under simulated physics before a single part is manufactured. Economic activity inside the digital layer rivals the physical economy in several sectors. The children of 2060 do not ask which world is real, they ask which world has better physics.
Number 11. The one-person billion-dollar company. Sam Altman said it plainly in 2025. There is a betting pool among tech CEOs for the year the first one-person billion-dollar company appears. He said it would be unimaginable without AI. He said it will happen. By early 2026, 36% of all new global startups were already solo-founded. The barriers that once made individual scale impossible, you cannot simultaneously code, design, market, do legal, run accounting, and strategize, had been obliterated by AI agent stacks. An entrepreneur in 2060 deploys a constellation of autonomous agents for customer acquisition, product iteration, compliance, and competitive monitoring. The founder provides vision, the agents provide execution. By 2060, this has reshaped what we mean by company, employee, and, most uncomfortably, fair. Number 13. Fully autonomous AI-run corporations. Take the previous technology one step further. Remove the human from the operational center entirely. By 2060, a significant fraction of digital native businesses are majority managed by AI systems, setting prices, managing supply chains, running marketing, iterating products, without a human signing off on individual decisions. Humans govern,
They set objectives, audit ethics, approve strategy. The machine executes. This was not abstract in 2025. Salesforce cut 4,000 customer service roles, citing AI agents. Amazon confirmed plans for 14,000 corporate position reductions. These were not factory jobs, they were knowledge worker roles. By 2060, that process has run through most of the professional economy, and the political pressure it generated forced the response that comes later on this list. Number 13, the fusion energy grid. In late 2022, the U.S. National Ignition Facility achieved fusion ignition, more energy out than in. Not a power plant, a proof of physics. But physics does not lie. By 2060, early fusion pilot plants operate in a dozen countries, alongside 700 gigawatts of new renewable capacity added in 2025 alone, a single-year record, and a fleet of small modular reactors providing firm, low-carbon backup. The grid of 2060 is the cleanest and most abundant in history, managed in real time by AI optimization systems across continental networks. Energy poverty, the condition of billions in the 20th century, is by 2060 a historical fact rather than a present one. That single change transforms everything.
Number 14. Flying vehicles and urban air mobility. The flying car was the broken promise of the 20th century. Every decade since the 1960s produced new renderings and new failures. Batteries were too heavy, safety certification too complex, vertical lift too expensive. By 2060, battery energy density has improved by an order of magnitude. Autonomous navigation has effectively eliminated pilot error, historically the cause of most aviation fatalities. AI-managed urban air corridors coordinate thousands of simultaneous low-altitude flights without collision. The Electric Vertical Takeoff and Landing Vehicle, the eVTL, is the air taxi of dense metropolitan corridors worldwide. Hyperloop died in 2023 when its most funded venture shut down entirely, a necessary lesson in the gap between compelling renderings and buildable infrastructure. But AI-optimized underground high-speed rail has connected city pairs once separated by hours into journeys measured in minutes. The world has contracted. Number 15. Climate engineering. Nobody wanted to use this. The math eventually made it unavoidable. By the mid-2030s, even the most aggressive emissions reductions could not prevent significant mid-century warming. Sea level rise was already locked in by existing atmospheric carbon. Coastal cities were spending trillions on seawalls. The taboo conversation, deliberately intervening in the global climate system, became impossible to avoid any longer. By 2060, internationally monitored stratospheric aerosol injection programs release fine reflective particles into the upper atmosphere, shaving a fraction of incoming solar radiation. Direct air capture facilities remove hundreds of millions of tons of CO2 per year. These are not elegant solutions. They are emergency engineering, contested at every level of governance. But the warming curve has bent. Not enough to undo what was locked in, enough to buy the decades that everything else on this list required. Number 16. The space economy. In 2024, the global space economy was worth $613 billion, and most of it was not moonshots, it was satellites, the invisible backbone of global logistics, financial systems, precision agriculture, and disaster response. Every autonomous vehicle on the road, every ship at sea, all of it dependent on orbital hardware. By 2060, that economy has crossed $2 trillion. Space stopped being a prestige project in the 2030s. It became infrastructure. And infrastructure, once load-bearing, gets funded permanently.
Number 17. Orbital Manufacturing. In 2024, Varda Space Industries recovered a capsule from orbit containing pharmaceutical crystals grown in microgravity, superior in molecular structure to anything manufacturable on Earth. The logistics of building in space and returning product to the surface had proved workable. By 2060, orbital manufacturing platforms in low Earth orbit produce high-value materials impossible to make in gravity. Ultra-pure pharmaceutical compounds, defect-free semiconductor substrates, biological scaffolds for tissue engineering. The market is not vast, the margins are extraordinary, and the economic logic it established, that space could pay, made permanent human presence viable on terms that didn't require government subsidy. Number 18. The Lunar Base. By the late 2030s, returning to the Moon was settled. Over 20 nations had signed the Artemis Accords. The question was what staying would look like. By 2060, a permanently crewed international lunar base near the South Pole, where crater shadows preserve ancient water ice, houses 60 to 200 researchers and operators at any given time. That ice becomes water for life support and hydrogen-oxygen propellant for outbound missions. The Moon is now a refueling depot, a materials testing environment, and the first proof that humans can sustain civilization off Earth. China's competing South Pole presence makes the Moon, for the first time, a place with multiple human settlements and active geopolitical friction. New territory, in every sense of the word. Number 19. Humans on Mars. The first crewed Mars landing happened in the late 2030s. 6 people, 420 days on the surface, flags from 3 nations. They came back. The public celebrated the arrival. What they missed was the economics. The mission cost had been driven down by an order of magnitude from 2020's estimates through fully reusable launch systems, AGI compressed spacecraft design cycles, and propellant sourced from lunar ice rather than Earth's gravity well. By 2060, Mars hosts a small permanent research presence, a dozen scientists and engineers, underground habitats pressurized against the Martian atmosphere, resupply missions arriving every 26 months when the orbits align. One-way communication delay, 4 to 24 minutes depending on geometry. This is not colonization, it is exploration with infrastructure. In human history, that distinction has always been temporary.
Number 20. Universal Basic Income. The political story of 2040s was the painful, contested reinvention of the social contract. Automation disrupted the wage relationship faster than democracy could adapt. Universal basic income arrived not as ideology, but as triage. In wealthy nations, it stabilized consumption. Across Africa, South Asia, and Latin America, modest transfers, delivered via mobile infrastructure, kept extreme poverty from becoming catastrophe. But UBI couldn't fix wealth concentration, couldn't cure the psychological damage of idleness, and couldn't close the gap between India and Luxembourg. What emerged was a patchwork, imperfect, uneven, but enough to make 2060 produce hope rather than collapse. Number 21. Quantum computing. In November 2025, IBM unveiled its Quantum Nighthawk processor and announced a target of fault-tolerant quantum computing by 2029. Google, Microsoft, and Amazon were all running parallel programs with similar timelines. The UN had designated 2025 the International Year of Quantum Science and Technology. By 2060, fault-tolerant quantum computers have become specialized pillars of the scientific and financial infrastructure, not replacing classical computing, but solving the problems classical computing cannot. Drug molecule simulation that once required years of supercomputer time runs in hours. Cryptographic systems hardened against quantum attack are standard.
Materials science problems, designing room temperature superconductors, engineering more efficient solar cells that were computationally intractable in 2025 are routine by 2050. Quantum did not replace classical computing. It became the instrument classical computing picks up when the problem finally demands it.
Number 22. Arcologies, the vertical city. Saudi Arabia's The Line, a planned linear city 170 kilometers long, 0 cars, all amenities within a 5-minute walk, was scaled back dramatically in 2024. But the idea behind it did not die. The pressure that generated it only intensified. By 2060, the Arcology, a self-contained vertical city fusing architecture with ecology, has moved from science fiction concept to operational reality in a handful of locations under the most acute land pressure. Coastal megacities defending against sea level rise, dense Asian urban corridors where horizontal expansion is physically impossible, climate-stressed regions where enclosing the living environment is the only viable option. These structures contain residential towers, vertical farms, water recycling, renewable energy generation, and commercial districts within a single integrated system. They are not utopias, they are engineering responses to a constraint that became impossible to ignore. Their residents live car-free, with a sub-5-minute walk to every daily necessity, in buildings that generate most of their own power and food. The city that does not sprawl does not consume the land the planet cannot spare. Number 23. Advanced 3D printing and additive manufacturing. In the 2020s, 3D printing was the technology that kept promising to change everything and kept changing only specialized niches. The problem was materials and speed. Layer-by-layer deposition was too slow for mass production and too limited in material properties for structural applications. Both problems were solved, not at once, but steadily. By the 2040s, large-format additive manufacturing systems using concrete, steel alloys, and composite materials were printing entire building components on-site. By 2060, the construction industry is unrecognizable. A house shell printed in 72 hours, customized to site conditions, requiring no form work and generating negligible material waste. In medicine, bioprinted tissue constructs, skin, cartilage, vascular grafts are in clinical use. In aerospace, engine components with internal geometries impossible to machine are printed directly from digital models. The factory floor of 2060 does not look like a factory. It looks like a room full of machines that read files and produce physical objects. The gap between design and manufacture has closed to near zero.
Number 24. The collapse of traditional education. The classroom, as the 20th century knew it, rows of desks, a single teacher, a fixed curriculum delivered to 30 students of mixed ability and interest, did not survive contact with what replaced it. By 2060, AI instructional systems with instant access to the sum of human knowledge have supplanted most of the functions previously held by human teachers for foundational education. Classes are no longer limited by geography. Students with similar abilities and interests learn together across continents, matched by AI for optimal cognitive fit. Universal translators have dissolved every language barrier. Full immersion virtual reality allows a student in Lagos to walk through ancient Rome or conduct a chemistry experiment in a simulated laboratory indistinguishable from a physical one. The consequences are stark and uneven. Global illiteracy has fallen below 1%, an achievement that would have seemed implausible in 2000. But the credential systems that once gate-kept opportunity have largely collapsed, generating political turbulence in the institutions built around them. What replaces the university is still being negotiated.
Number 25. Human-AI cognitive augmentation. The previous technologies treated AI and humanity as parallel tracks. This one merges them. By 2060, neural interfaces combined with persistent AI systems have produced a mode of cognition that has no historical precedent. A human mind with on-demand access to the processing power of AI, integrated at the level of thought rather than tool use. An augmented professional does not ask an AI system a question and wait for the answer. The answer arrives in awareness, the way a memory does, or an intuition. Research scientists with augmentation move through hypothesis spaces at speeds their unaugmented peers cannot follow. This has not resolved the inequality it creates. The gap between augmented cognition and unaugmented cognition is the civil rights issue of the mid-21st century, and it is unresolved in 2060. What is resolved is that the capability is real, it is widespread among those who can access it, and it is compounding year on year. Every prior era had its cognitive advantage determined by genetics and education. This one has added a third variable: hardware. Number 26. The longevity escape velocity threshold. Longevity escape velocity is the point at which medical science is extending healthy human lifespan faster than time is passing. Gain more than 1 year of healthy life expectancy per year of calendar time, and you are, statistically, running alongside death rather than toward it. The research community debates fiercely whether this threshold has been crossed by 2060 or remains a decade away. The answer depends on which aging mechanism you examine and how well the combined stack of senolytics, partial reprogramming, CRISPR therapies, and organ replacement is actually performing across diverse aging populations over long time horizons. But the debate itself is the news. The fact that this question, whether humanity has escaped the mortality clock, is being asked in earnest by serious scientists in peer-reviewed journals is a measure of how far the biology of 2060 has traveled from the biology of 2025. The first generation that might live indefinitely is already alive. Whether they actually will is not yet written.
Number 27. The diseases that remain. This is the entry on the list that earns the list's credibility, because a documentary that only tells you what went right is a commercial, not a history. Antimicrobial resistance remains the WHO's top global health threat in 2060, as it was in 2025. Over 1.27 million people died directly from resistant bacterial infections in 2019. The numbers have not improved proportionally in 2060, despite AI-accelerated antibiotic discovery, because resistance evolution is faster than any therapeutic generation can contain. The race is not being won, it is being run. Neurodegeneration, Alzheimer's, Parkinson's, frontotemporal dementia, has proven stubbornly resistant to the therapeutic logic that reformed oncology. In a world where people live longer in physically younger bodies, the proportion living long enough to develop these conditions is rising sharply. Dementia is the defining medical challenge of the extended lifespan. Progress opened the next door onto a harder room. It always does. Number 28. Digital memory preservation. This one sits at the edge of what 2060 can claim to have achieved, but it belongs on the list because its early forms are real. Neural interfaces combined with AGI systems capable of modeling personality from decades of behavioral and conversational data have produced what developers call digital continuity and what critics call something between a memorial and a deception. A person who has worn a neural interface for 30 years has generated an enormous data set of cognitive patterns, emotional responses, values, and characteristic ways of reasoning. When that person dies, an AI trained on that data set can respond to questions in ways that reflect their perspectives with unsettling accuracy. Whether this constitutes continuation of identity or a very sophisticated shadow of one is the philosophical question of the era. The technology exists. The question of what it means will be answered slowly, painfully, and beautifully by the generations that inherit it.
Number 29. The AGI Civilizational Multiplier. Step back from the individual items. Look at the pattern. Every technology on this list is accelerated by the same underlying engine, a class of AI systems generalizing across scientific and engineering domains with minimal retraining. The self-driving laboratory discovering cancer drug candidates. The surrogate model designing fusion reactor superconducting magnets. The climate simulation system identifying the precise aerosol injection quantities that minimize warming without triggering monsoon disruption. The same architecture, every domain, simultaneously. The IEA documented data center electricity demand growing at 15% per year by the mid-2020s. That was the physical footprint of the new scientific substrate. Hundreds of billions of dollars of compute drawing extraordinary quantities of electricity from the renewable grid, from small modular reactors, eventually from early fusion pilots, generating the intelligence that compressed every other discovery timeline on this list. The AGI revolution is not a technology. It is a multiplier applied to every other technology at once, and it was already running before most people understood what it was.
Number 30, Android law enforcement and AI surveillance. And now the entry that carries a different weight from every other on this list, because not all of what 2060 delivers is wonder. By 2060, humanoid robots operate alongside human officers in law enforcement contexts in dozens of jurisdictions, monitoring crowds, patrolling transit networks, responding to incidents with a speed and consistency no human can match. In controlled environments, they are genuinely useful. But the line between useful presence and tool of authoritarian control is not maintained by the technology. It is maintained, or not, by the political systems deploying it. In China and other authoritarian states, AI-powered national surveillance has matured into a system of a scope and granularity that has no historical parallel. Facial recognition cameras track movement in real time across hundreds of millions of people. Social scoring systems informed by AI analysis of digital behavior shape access to credit, employment, and travel. Android law enforcement officers are deployed in public spaces with directives that operate entirely outside civilian oversight structures. The technology itself is neutral, its application is not. The world of 2060 is a world in which the same capabilities that defeat cancer and reach the moon can also be used to build the most effective instrument of population control in human history. Which version of 2060 you live in depends entirely on which political system surrounds you. That fact is not a footnote to this list. It is the most important sentence on it.
If you were born in 2000, you were 60 years old in 2060. You are the last generation that truly remembers the old world. You remember a time before the silence of autonomous fleets, back when the smell of gasoline was a daily reality. You remember when artificial intelligence was just a buzzword in a headline, not the heartbeat of every industry on the planet. You didn't just watch history happen, you survived it. You saw the decade where cancer mortality finally collapsed. You remember the exact moment you saw that first Neuralink patient playing chess and the realization that the boundary between human and machine had forever blurred. You watched the solopreneur revolution, where a single person, backed by a swarm of AI, built a company that outproduced entire nations. You were there for the moonlight, the night the Lunar Base grid first twinkled back at Earth. You watched the Mars pioneers return, aged and triumphant, and you saw the fusion scientists, the ones the world had doubted for a century, finally step back as they lit the world with the power of a star. You understand what no generation before you could. The future is not a place we simply arrive at. It is a craft. It was built by the choices, the investments, and the sheer stubborn grit of people who had every reason to walk away, but chose to build instead. But it's also a fragile thing. What was made can be unmade if we lose our way.
The world of 2060 is the masterpiece of your lifetime. So I have to ask you, looking at where we are today, which of these breakthroughs do you think will change your life the most? Is it the star power of fusion, conquering our own biological limits, or the quiet revolution of AI? Drop your thoughts in the comments. I want to know which future you're betting on. The road to 2060 is being paved right now. Subscribe to Vivid Futures to stay on the map. We have a lot more to show you.